Hey there. In this video, I want to walk through the data analysis activity 2 concerning central tendency and variability. In this activity, we're going to learn how to apply the concepts that we learned about measures of central tendency and variability and how to conduct those analyses in R. So for this activity, you're going to be giving a research scenario, and then you need to identify, according to that scenario, uh, what kind of data it is, what is the most appropriate measure of central tendency, and what's the most appropriate measure of variation. And you can see here, we're going to describe for each one of these the shape of the distribution. So we're going to talk about it. Is the distribution skewed? Is the distribution, what's the modality of the distribution? We're going to print and interpret an appropriate graph of the distribution. We're going to indicate which measure of central tendency uh, is the best and then justify that response. We're going to discuss which measure of variation is is the best and justify that response. We're going to answer each question, and then I'm going to show you how to compile your R output and submit it. So for so for this activity, let's go ahead and open R. Uh, First thing you can do is go to File, New File, and I need to hide my flooding page. File, New File. Let's do a new R script. The first thing I always like to do is add in a comment here with my name and the name of the activity. The next thing I want to do is load the packages that we'll be using. So we're going to probably use the janitor package to get frequency tables. So let's load the janitor package with library janitor. There it is. And let's load the ggplot2 package for graphing. So let's load ggplot2. Next, it asks us to read in our data set. Our practice.2, our practice2.csv data set is it's located on Canvas. I've also posted it on the web, so we can just use this line of code right here to load the data set. So paste that into R. I like to keep I always like to keep comments in here so I know what's going on. And now I'm just copying and pasting that syntax into R. As long as your cursor's at the end of the line, we can click run and we can see over here that our data set has been loaded into our environment. Uh, we can see that there's 43 observations of 3 variables. If we click on this part right here, or just type view and then the name of the data set into the console, we'll pull up like a spreadsheet of the data. We can see there are 3 variables in the data, one about weight, vacation, and house are the names of the variables. And then you can see that it has responses in there for 43 individuals. Uh, so what does this line of code say right here? This is saying that we want to read in a CSV file, which is essentially just an Excel file, a comma separated value. I've put it on my website. We can just pull it straight from the internet, and let's assign it to an object that we're calling dat. So we've just saved, and then our objects come over here into our environment window. These are all the objects that we have stored into R in this session. So let's look at the first problem. So on the first day of PE class, Coach Jackson decided to weigh his students so he could determine how much each student had lost or gained during the semester. Use the variable weight in the practice exercise data set and determine the best way to describe the weight of his students. So the first thing we might want to do, so let's put it in here. This is the weight problem. Let's examine a frequency table for weight. We could use the table function out of the janitor package, which is that tab YL function. And we can tell R that we want, if we want to tell that we want the weight variable out of the DAT data set, we have to tell it we want the DAT data set. You want to index it with the $sign, and then we just want the weight variable out of there. And if you don't know what the variable names are, you could look back here and see that we have weight, vacation, and house. We could run this. Oops, I forgot to run my, once I typed in, I forgot to run the library commands. So now we should be able to run it. Oh, there we go. Now we get a nice frequency table. Weight's more of a continuous variable. So we see a lot of people, a lot of students here have, there's one person with that particular weight. You know, one person weighed 73 pounds. Two people weighed 109 pounds. One person weighed 166 pounds. So sometimes the frequency table, when we have continuous data, isn't all that informative. Since weight is more measured on interval ratio scale, it's more continuous. Let's try to visualize the distribution with the histogram. We can do that using the hist function, and we give it the same information. We want the weight variable from the DAT data set. Remember, R is an object-oriented language. Everything is stored as an object. So to look like which object you want and what element out of that object do we want. So we want the weight variable out of the DAT object here. We'll use a little, this will be a histogram so we know what we're doing here. We could click run. And then we have a nice histogram. So it gives us a nice visual of the shape of the distribution. And so I would say, looking at this, since the histogram looks pretty symmetrical, you know, the majority of cases are clustered here in the center. Fewer cases are on the end of the distribution. The distribution doesn't look skewed one way or another, then I would say we could be pretty confident using the mean as the measure of central tendency here. And then probably using the, since we're using the mean as the measure of central tendency, then it's appropriate to use the standard deviation as a measure of variation or spread, since remember the standard deviation is based on deviations from the mean. So since these are continuous type data, histogram would be a good way of representing the data. Since the data aren't skewed one way or the other, the mean and standard deviation would be good measures of central tendency and variability. So let's, we can get the average or the mean by just using the mean function, and we can get the average weight. We could do the same thing with the standard deviation. and we could run both of those. So we see the average weight is 131 pounds with a standard deviation of around 32 pounds. So that's how much each score on average deviates from the average score. So this would be our measure of central, our measure of variation. An alternative, we could use the histogram as our as a good graph or visual. You could also use a box plot uh, as another good uh, graph or visual, and we can see here that we get the median weight, the 25th percentile, the 75th percentile, and then this is like 1.5 times the interquartile range. That's what the whiskers tend to go out to. So let's see, do we answer all of our questions? Let's come back up to the top. So the shape, remember we described it, that the shape look pretty normally distributed. Most of the scores were in the middle, few scores were at the end. It seemed to have a unimodal distribution. And then an appropriate graph in this case would either be a histogram or a box plot. You could also use a frequency polygon. There are a lot of different options here too. The best measure of central tendency, I'd argue, is the mean, since the data are interval ratio and they're not skewed one way or another. The mean is a good measure of central tendency. For variation, since we're using the mean as the measure of central tendency, I'd use a measure of variation that's based on the mean. So I'd choose the standard deviation in this instance as the measure of variation. What is the to determine the best way to describe the weight of the students? That's what we decided was the average weight and standard deviation. I think we answered all of our questions here. At the end, I'll show you how to compile your R output. So let's see, let's look at number 3. Marianne is planning a summer vacation. However, she cannot seem to decide what place to visit. She's narrowed her choices down to 4 places: Hawaii, Cabo, the Bahamas, and New York City. She decides to put a poll on her Facebook site and let her friends decide where she should go. Use the variable vacation, the practice data set, to determine where Marianne should go on vacation based on the results of her Facebook poll. So let's go back into R. Let's do number 3. This is our vacation data. Oh, can't spell here. So let's get a table. Let's get a frequency table of our of this variable. And when the first order of data analysis, run frequencies on your data, see what they show. So let's do, we'll use the base R table function so you can see the difference. Remember, we can take our data set's called DAT, and the variable we're interested in is vacation. We'll also do the janitor table function. So you can see the base R table function just puts them out in like a row vector. So you can see 15 people chose Cabo, 11 chose Hawaii, 9 chose New York City, and 8 chose the Bahamas. The nice thing about the table function, I think, is that it not only gives you the counts, but also the percentages. So you can see around 35% of the Facebook respondents chose Cabo San Lucas, and 26% chose Hawaii. So you get more of a breakdown of the percentages as well as the frequency counts. So since these are nominal data, right, we can put into distinct categories, but there's no logical ordering to the categories. These are nominal data. Since these are nominal data, the shape of the distribution doesn't matter. We can change the shape of the distribution by just arbitrarily changing the numbers that we assign to Cabo, Hawaii, New York. So the best way to visualize these data, I think would be a bar graph. We can get a bar graph using the ggplot function in ggplot2. We just give it the name of our data set, and then we want to add on a geom of a bar plot. The aesthetics are our x variable is equal vacation. There we go. You could add on, like if you wanted to add on, I like the theme minimal. Whoops. I like theme minimal, but that's just an optional thing. We can also add colors if we wanted to the bars. I'm just going to keep this one simple. And there we go. Now we have a visual representation of the distribution of data. Another alternative you could also do if you're into pie charts, you could create a pie chart. To make a pie chart, you need to save out a table of the distribution. So we'd need to save an object like vacation data, table, vacation. So basically what we did was we saved this output here as an object we called vacation data. See, exact same thing. Then we could just use the pie function to run a pie chart on that table. And so you'd get a quick little pie chart. I prefer a bar chart. I think they're easier to read and judge the area, but it's your preference there as well. Let's go back up here to the top. Describe the shape of the distribution in terms of skewness and kurtosis. Since the data are nominal, the shape of the distribution doesn't matter. Skewness and kurtosis are meaningless with nominal data. The data are unimodal. The most frequently occurring response was Cabo, and the most appropriate graph, I would say, is a bar graph. Indicate the best measure of central tendency. In this case, it would be the mode, right? Because it is nominal data. The mean and the median don't have any substantive meaning for nominal data. Variation, we don't care about variation with nominal data. It doesn't make those don't have any meaning for nominal data. The range, variance, standard deviation, interquartile range are meaningless with nominal data. So let's answer our question. So where should Marianne go? Well, based on our Facebook post, she should go to Cabo. All right, let's see about number 4. Okay, Carlos and Jill are buying a house in Knoxville. They decided to purchase an antebellum style home in the old city built in 1889. They are paying $575,000 for the new home. Use the variable house in the practice data set. Determine whether Carlos and Jill are making a good purchase based on the price of homes in the area. So let's open up R again. Oh, there we go. Let's do a comment. Let's do number 4. Housing data. So first thing I want to do is, since housing data are probably, interval ratio, we can run a frequency table if we wanted to, but again, it's probably not going to be as informative because look, there's a lot of homes that just sell for a single price, right? I think there was one there that had 2 at that price. So it may actually be more informative if we looked at like summary statistics for it. Before we do that, let's get a visualization of the data. Since these are interval ratio data, let's get a histogram. This should be histogram. There's our data house. Look at that. Uh, so we can see in this histogram that the data look pretty positively skewed or right skewed. The majority of the houses look like they're selling around like the 500,000, 300,000, like 800,000 type range. It looks like there are several houses that are selling for like 1.5 million plus over here. So it looks like we have evidence here of a skewed distribution. So here we have interval ratio data, but the data aren't normally distributed. In this case, when the data are skewed in one direction or the other, the mean gets pulled in the direction of the skew. Uh, so in this case, the most appropriate measure of central tendency for continuous data that are skewed is the median. So we can do the median as a measure of central tendency. So let's do that house. And since the median is the measure of central tendency, we probably don't want to use the standard deviation is the measure of variation, mainly because standard deviation is based on deviations from the mean. If the mean is an appropriate measure of central tendency, then we shouldn't use a measure of variation that's based on that measure of central tendency. So I'd probably use the interquartile range in this case, which is just the 75th percentile minus the 25th percentile. So we can have our median as our measure. So now we have the median home price is 583,000. Uh, and the interquartile range, so kind of the spread of scores in like the middle 50% is 239,000. Another way of getting like quick summary statistics is just using the summary function. Let's do data house there. And this one's nice. Summary function is nice. Uh it gives you the minimum score, the minimum score. So in this case, the minimum housing price in the area is $350,000. The maximum housing price in the area, which was $3.5 million. There's our median home price again. Look how the mean is being pulled in the direction of the score. So the median home price, if we were just to line all the home prices up from smallest to largest, the one that's smack dab in the middle is the median. Notice that the mean is over the third quartile. In this case, it is 805,000 because it's getting pulled or influenced by those really large home prices. This is why you will see a lot of times when people report the average home price in there, you always can report the median sell price. Uh, so we can see what the median, and then you can see the difference between the third, 750 minus, there's our interquartile range. So you can see how it's computed uh, as well. A histogram, I think, is a good representation of the distribution. Also think a box plot. Yes, okay. Box plot. Yep. There we go. And so in the box plot, you can see the skew as well, too. So you can see the middle range of scores here, which is still between the 500 and, about 510,000, 750,000. There's the median. And then you see all these outlying points, which are more than 1.5 times the interquartile range. That's where these whiskers extend to. And so you can see the outliers, and you can see that gives you the visualization of the skewness of the distribution. So let's go back. Oh, so the shape of the distribution, the shape looked pretty right skewed, like positively skewed. Distribution seemed mostly unimodal. Didn't seem to have multiple peaks in that distribution. The most appropriate measure of central tendency we determined was the median, because the data are interval ratio but are positively skewed. The measure of variation, I would choose probably the interquartile range in this case. Uh, Answer the specific research question. So do we think Carlos and Jill are making got a good price? So they're paying 575,000. The median was 583,000, so it's right there under the median. Might, without knowing any more information about it, I might say yes, just based on that. All right, so let's look at the last one. So we want to enter the following salary data into R. I want you to compute the mean, median, and mode. What's the preferred measure, central tendency, and why? All right, so we have a bunch of salary data here. I'm gonna make sure I copy it so I don't get it wrong. This is number 5, salary. All right, to enter data into R, uh, first I'm gonna do is just copy and paste that data that I have so I don't lose it. I need to create a name, a variable name. In this case, I'm going to create, well, in this case, just an object name. I'm just going to name it salary. I'm going to assign salary a vector of salaries. So in this case, I need to use the combine or concatenate function. And I want to combine all of these things. So all I'm going to do is just take what I have. I'm just going to delete all of the dollar signs and add a comma between each one. I think that's, in this case, is probably the easiest way of entering these data. I'm going to need a uh, end parentheses here. Uh, I'm going to, you could highlight all of those, click Control F, and I want to take the dollar sign, and replace it with nothing. So I'm just gonna go through. That's one way I can take away all these dollar signs. There we go. I don't want to take away all of them. And then just come through and add a comma at the end of all these. Whoops. And I need to take away. I just noticed that. Because R is going to think that anything after a comma is a different input. So I want to take away the commas in the salary ranges and put commas actually at the end of my variables in the list. Uh, the other way you can do is just enter it manually as well too, but I like to just copy and paste things sometimes so then I don't mess up. Uh, but here you just have to remember. Whoop, that was 22. I deleted a 2. There we go. All right. So now I have the salary data entered. I can click run. I should have a new variable over here that has salary, should be 20 numbers. Let's get a table of salaries. And then I can go back to my Word document and make sure I have these. I'd probably go through here and like cross them off. There's a 14,000 check. 120,000. Check. 221s, 222s. There's 121, 221s, 222s. That was one, two. I just like to make sure they're all in at 423s. One, two, three, four. 124, 230s. There's 24. One, two. Let's have a 31, a 33, a 40, oh, a 31, a 33, and a 40. I have a 52, a 64, a 60, 52, 60, 64, and an 1800. Uh, or sorry, 180,000. All right, so we got them all in there. We checked to make sure the data were entered correctly. Now we can start describing the data. Since salary data are interval ratio, we can get a histogram of our salary data. I can just enter salary this case because I just entered it as a specific variable. It's not part of a data set, so I don't need to index anything to get it. I can see the histogram here. As we could probably tell when we were entering the data, this one value of 180,000 is going to really skew the distribution. So it's again right or positively skewed. It's interval ratio data. I'd probably use the median as the measure of central tendency and the interquartile range as the measure of variation. So we can see the median salary is 23,500 and the interquartile range. We could do summary, which gives us all the same information, just one command. You can see how the means pulled in the direction of the skew. Again, good, it's even larger than the third quartile. So let's go back here. The shape of the distribution, it seemed unimodal. It's had one peak. It was positively skewed, and either a histogram or box plot would be an appropriate graph. Since the data are interval ratio and skewed, the median would be the measure of central tendency, and interquartile range then would be the measure of variation. Oh yeah, we were supposed to calculate the mean, median, and mode. My preferred measure of central tendency would be the median we already discussed, but we can get there's the mean and the median. The mode, the best way I think to get the mode is just to run a table function and see which one occurred the most frequently, the 2300. And you could do it either way or the whichever one you prefer. You can see that's the one that occurred most frequently. There is no mode function in art, especially not the way that we're discussing the use of the word. So I think this is the easiest way of getting the mode. So the mean, median, mode are the median and the mode are pretty similar to each other, 23,000. And the median 23,500. And the mean is pulled in the direction of the skew in this case. Oh yeah, the last thing then is compile your R output for this activity. So to do that, unless you have your output done, is to go here to File, Compile Report. Oh, before we do that, we probably want to save this. So we'll go to our little save button here, pick where on your computer you want this stored. I have a Google Drive for this class, ESM 250, Central Tendency. So this is practice exercise 2. I'll go to file. So I saved it. I'm going to compile report. And then I'll usually save it as a PDF or Word document. So that way, when you turn it into me, I can make comments on it. If you use HTML, I can't really comment on those files. Go to compile. Uh, if you get any errors, what this is doing is basically, oh, there it goes. And then it'll open up and it'll save it out in a Word document. Here it has what you typed in to R and then what the output that came out from those commands. Basically, what compile is doing is starting that line running everything from the first line all the way to the end. If you get an error message, it's probably because you have an error somewhere in your syntax file right here. You can email me and I can help you troubleshoot that. But that's usually the case. If there's an error anywhere in here, you either need to comment it out and run it again or fix the error. Well, that is our walkthrough video for the data analysis activity 2. If you have any questions, please feel free to reach out to me. Thank you and happy modeling. Figure out how to turn this off. Okay.